Today we will begin exploring one of the most important concepts in C++ object-oriented programming. We will focus on two fundamental building blocks, classes and objects, the foundation of object-oriented programming. By the end of this lecture, we should be able to define object-oriented programming and its main principle, understanding the concept of a class and object, learn how to define and use a class in C++, and explore examples with attribute and method. For better understanding of object-oriented programming, we are going to compare it with traditional procedural programming. In traditional programming, we focus mainly on functions and the procedures. The program is divided into steps and functions. But in object-oriented programming, we focus on objects, which combine both data and method into a logical unit. This makes the code more modular, reusable, and easier to maintain. Now, what is a class? A class is a blueprint or template that can combine both attributes and behavior. The object is an instance of that class, a real representation created from the blueprint. Here is we define a car class that has 3 data member, color, engine, and model. It also has a method called start, which describes what car can do. Once we define a class, we can create actual objects from it. For example, my car is an object of type car. It has its own color like red, blue, orange, and engines like electric, gasoline, and diesel. And its model like sedan, SUV, or pickup. We can then call its method, such as start, to make it perform actions. Remember, different objects can share the same classes, but have a different data. Just like different cars can be built from the same design, but differ in color or engine type. In C++, access specifier determine how can access the member of class, that is, which part of the program can see or modify the data and methods. Let's imagine our class as a company building with the 3 different levels. The public section is like the company lobby, open to everyone, anyone, even visitors, can enter freely. Similarly, when a member is declared as a public, any part of the program can access it directly. The protected section, like the employee, only floor, only authorized people, the staff, and managers can enter. In C++, this means members declared as protected can be accessed within the class itself and by derived or child classes, but not only outside functions. Finally, the private section is like the CEO's office, which is completely locked. Only the CEO, or our case, the class itself, can access what's inside. Member declared as private are hidden from everything outside the class, including derived classes. This system of access control helps us to protect data, organize code, and enforce encapsulation, one of the main principles of object-oriented programming. A constructor in C++ is a special function that runs automatically whenever we create an object from a class. Its main purpose is to initialize the object data, giving it starting values right at the moment of creation. Think of that like preparing a new car before it leaves the factory, setting its color, engine type, and model before it's ready to drive. For example, in our car class, the constructor can automatically assign values to brand and year when we create a new object. That means we don't have to manually set them one by one later in the code. Using constructor makes our code cleaner, safer, and more reliable because every object begins its life properly configured. Now that we understand what is a constructor and how to initialize objects, let's jump over to VS Code and write a simple program to see it in action. We'll create our car class, add a constructor, and then make an object to test how everything works in real code. So now we can create a car class. It's a car. Then going to create variables. I'm going to change this to color. And model also to engine type. Okay. Engine. So this is the constructor that we will initialize the variables. Also, we're going to create a function to display information. After that, we're going to create a main program to create two objects from the same type and initialize them with different three variables for color and model and engine type. And here, both objects will use the display information to print the information from here. So I'm going to run this from here and see the result for two objects. Let's move to the presentation. Back to slide 8. The advantage of classes and objects help us to organize our program around real-world entities rather than just the steps or functions. This approach makes our code modular. Each class handles one clear responsibility and reusability because the same class can be used to create many different objects. It also improves readability and maintenance since changing one part of the program do not affect other unnecessarily. Most important, it allows us to model system more natural. A student, a car, a drone can each become an object with its own data and behavior. In short, classes and objects lead to cleaner or more reliable and a scalable program. Let's summarize what we have covered today. We learned that a class is like a blueprint. It defines the structure and behavior of something. An object is an instance of that class, a real version. that holds its own data and performs actions. We also explored how access specifier control visibility, public, protected, and private, and how constructor automatically initialize an object when it's created. Together, these ideas form the foundation of object-oriented programming in C++. In our next lecture, we will go deeper into encapsulation and constructor to see how we can make our program more secure and better structured. Before we finish today's session, I'd like you to try a short exercise to apply what we have learned. Create a student class with 3 attributes: name, age, grade, and 1 method to set data and to display or print them. After defining class, create 2 objects, for example, one for Ali and one for Sarah, and display each student's information. This is small task will help you to understand how class defines structure and object hold actual data. It's the first step toward writing complete object-oriented programming on your own.